All right, guys. So this was a problem that was on Unit 5 quiz from College Board, and I did it with the class yesterday, the people who were on the Google Meet yesterday, but apparently I didn't record it correctly, so I'm still figuring out how to record my work when I'm on those things. Plus, my phone is not really doing much charging for me, which kind of sucks, so trying to figure all this out um, as we go along, but hopefully we'll work it out. Okay, but anyway, let's go over this problem. So we have this differential equation that's given, and they give you an initial point of 0, 2. Okay, we want to write the equation of the tangent line at 0, and then use that to approximate, 0.5. So remember, the derivative is going to give us our slope. So what I'm going to do is plug in the point 0, 2, because that's what's given to us, and we want to have this at 0. So when you do that, you're going to wind up with 2 times 2, or 6 is going to be our slope. So for the tangent line, our equation is going to look like y minus 2 equals 6 is our slope, x minus 0, and that gives us 6x plus 2. If we want to approximate 0.5, we just plug in 6 times 0.5 plus 2, and that's going to give me 3 plus 2, or 5. So tangent line, and then the point, the value at 0.5. So that's 1 point here and 1 point here. All right, on this next one, we have, they're looking for the second derivative, all right, at the same point, and they want to know if it's concave up or down. I'm just going to move this up a bit. Okay, so for B, so when we're doing second derivative, you're taking the derivative of our differential here, right? So that's going to be -2, and then don't forget your dy dx. And so dy dx was 10 minus 2x, 2y, sorry, 10 minus 2y. So that gives us -20 plus 4y. And they want to get the second derivative at the same point, 0, 2, so I'm going to plug in 0, 2. So -20 plus 4 times 2, and that's going to give me -12. So that would give you 1 point as well. The next point that you get is determining whether it's concave up or down, and the reasoning behind it, okay? So since d squared y over dx squared at 0, 2 is negative, f is concave down. So that gives you another point, but you have to state that the second derivative is negative, and then you could say that it's concave down. So again, that is the only way you're going to get a point for that one. On the next one, we have, okay, so the particular solution. So this one is probably going to take us the longest, right? So I'm doing this, part C. And this is where you have your differential 10 minus 2y. And you're using that initial point of 0, 2. So separate, integrate. So remember, if you're doing this, the shortcut would be 1/2 negative, since that is our reciprocal of -2, and then it's ln 10 minus 2y, and that's going to equal x plus c. So remember, what I'm doing here is taking the integral of both parts. Okay. On the next one, on the next step, you can multiply everything by -2. Remember, c is still c, so even if you multiply any constant by another constant, it's still going to be c. And then to get rid of the ln, we can raise everything, e raised to everything, and then the part c is just going to come down in front, right? C e to the -2x, okay? All right, so let's find out what c is. So I'm going to plug in our point, and so I'm going to get 10 minus 2 times 2 is equal to c e to the 0 power, which is just going to be 1. So c in this case is going to be 6. So let's plug that back in. And then all you're doing now is just solving. So I'm going to subtract 10 to both sides, and then divide everything by -2. So I get -3e to the -2x plus 5. All right, so this is 4 points. 4 points, you are getting a point for separate, a point for doing the antis, a point for using, right, the initial point to get C, and then a point for your final answer. Next thing we're doing is the limit of this function as, okay, the limit as x goes to infinity of our function that we have here. So limit of a constant is very easy, right? That's just going to be the constant itself. This is where you have to know what that looks like and what your limit is going to be. So anytime it's e to the negative, right, e to the -x, it's going to look like this. And you could see as x gets bigger and bigger or approaches infinity, right, you could see that the function is getting closer and closer to 0. So this is actually 0 plus 5, or just 5. And that one was only 1 point.